Okay, 10.4 is on what they call inscribed angles. The other day we did a central angle. A central angle, okay, just for review a minute, a central angle looked like this. A central angle was from the center and the two endpoints are somewhere on the circle. That makes this a central angle. Okay, now today we're going to do inscribed angles. Inscribed angle is an angle that has its vertex on the circle and its side contains the chords. So an inscribed angle is going to look like this. It's going to be the vertex is on the circle. Okay, so there's a difference. Central angles from the center of the circle, inscribed angles from just a point on the circle. Okay. Theorem 10.6. Yeah, it would be this angle. Yep. Okay. Theorem 10.6, an inscribed angle theorem. If an angle is inscribed in a circle, then the measure of the angle equals half the measure of the intercepted arc. Okay? Or the measure of the intercepted arc is twice the measure of the inscribed angle. So, by our picture, if I said this angle 1, okay, is half the measure of this arc. So if I said the measure of that arc was, I'm just going to make up a number. If I said that was 120 for that arc, well, that angle would then be 60. It's half. Or they can turn it around and say, if I give you angle 1 is 60, then the arc is twice that. Yeah.
So, well, a central angle is
the same. And inscribed, the angle's half the arc. Central angle's the same. Like if I said up here this was 50, then this angle's 50. Yeah. Central angle's the same. Inscribed angle's half the arc. Okay? Okay, keep going. Example 1. In circle F, the measure of arc, WX, is 20. Label that on your picture. Okay, WX is 20. The measure of XY is 40. That arc is 40. The measure of arc UZ is 108. Okay? That whole thing is 108. Okay, the measure of arc UW, okay, and YZ are equal. So mark those as congruent. Okay? Find the numbered angles. So we've got to find all the angles. Okay? Angle 5 is what? No.
Oh, no. 54.
54. Okay? So the measure of angle 5 is 54 because it marks out this, it maps to this inscribed angle is 5 and this arc is 108, so it's half that, 54. Angle 3, hang on. Angle 3 also marks out that, doesn't it? So measure of angle 3 is also 54.
Angle 4 goes from X to U.
But there's another one you can get in there.
Angle
2 is 20. Right, because angle 2 is right here, and it maps off to this arc 40, so it's half that.
108 plus 20 plus 40. Subtract from 360 and divide by 2. Right?
Yeah,
Divide the arc.
Okay, so we've got, he's saying add 108, right, and 20 and 40, and then these two are the same. All the way around in the circles, how much? 360. So we can take 108 and 20 and 40, or 60 if you want to. So that'd be 168, right? Check my arithmetic. Okay, and then 360 minus 168. Is it 192? Okay, and then he's saying divide these by 2 because they are congruent. 192 divided by 2 would be I get 96. You agree with that? Okay, so this arc is 96. This arc is 96, but one is half of it, right? So angle 1, whoops, measure of angle 1 is 48 because it's half that arc. Keep going. Did we find them all? 1, 2.
4 and 48 too. No, 4 is 68. No, 58. Right?
4 is not central. It's not inscribed. So how are you figuring it?
No, because it's not.
What's angle 2? Do we have enough in this triangle? Look here. Do we have enough? We got angle 2, right, is 20. We've got angle 3 is 54. 3 angles in a triangle add up to,
180.
so what, can't we add those two together and subtract from 180? 74, 106. See what I'm doing there?
Yeah.
So measure of angle 4 is 106. Kind of like a little game you play there. Okay. So you got to remember, central angles are the same as their arc. Inscribed angles are half their arc. Okay, let's keep going. Theorem 10.7. If two inscribed angles of a circle or congruent circles intercept arcs or the same arc, then the angles are congruent. For example, if you look at like DAC, okay, they're looking at this DAC, okay, that angle maps out that arc, and DBC goes to the same arc, okay, so this angle has to be congruent to that angle. And it would go the other way too. If I look, if I said this ACB maps off this arc and ADB maps off arc AB, then those angles are the same also.
Do they say DAC, they convert triangle CDB?
The angles are the same, yes.
Or, like one's mapping out the bottom arc and one's mapping out the top arc.
No, they got to map out, well, they either have to map out the same arc or congruent arcs. They have to be congruent arcs.
So one can do top, one can do bottom.
If it was given that they were congruent arcs, then you'd be okay. Okay. Look at the, well, they give you another example there. So inscribed angles of congruent arcs are congruent, and inscribed angles of the same arc are congruent. So they're basically giving you this one. If they tell you that this, if they're, and they have to show it on the picture. Okay, like if those arcs are congruent, then this FAE is congruent to CBD. Okay, those angles that would then be congruent. Okay. Okay. Theorem 10.8. If an inscribed angle intercepts a semicircle, the semicircle is how many degrees? 180. So the inscribed angle has to be half that, so it's got to be 90. Okay, so it's got to be a 90-degree angle. So if it goes and maps out the arc, if that's a semicircle, then this angle's got to be 90. Okay. Theorem 10.9 says if a quadrilateral is inscribed, quadrilateral, 4 sides, is inscribed in a circle, then its opposite angles are supplementary. So if you look at this picture, angle A, opposite angles, angle A plus, it would actually be the measure, and the measure of angle C, what do the supplementary angles add up to? 180. Okay, and then measure of angle B plus the measure of angle D, they add up to 180. They are supplementary. Okay? Okay, that should be it. Okay? I'll give you time on your assignment. Now, remember there's no school. Yep.
Amen.
Amen. Except school for us. Yeah. Something's always wrong with that.